So imagine that you have a ball that's being launched straight out, no angle at all. Let's say it's a cannonball, and the cannon is pointing straight in the horizontal direction. And it's launching it off a building so that it's going to fall some distance. This cannonball isn't going to go straight down. It's not just going to fall off the building. It's going to go out and then fall some distance from the building. So when you solve this type of problem, you have to separate the x motion from the y motion. The x motion is going to be going straight out, and it's going to keep at a constant velocity. There are no other forces on this cannonball, no forces pushing it back if we neglect air resistance, which we will. No forces pushing it forward after it shoots. So since it has no unbalanced forces on it, it is going to be moving at a constant velocity in the x direction. In the y direction, it has gravity pulling down on it. And so in the y direction, it does have a force, and so it will experience acceleration down. So the way that I solve these problems, I set up a chart, VI, VF, A, T, D, D for displacement, and then I set it up in the x direction and in the y direction. So we do have to have some information, and I'll give you some in a second, but there are some givens that we know without even having any information at all. The first is that since it's falling because of gravity in the y direction, then the acceleration due to gravity is negative 9.8. We're just going to simplify that with negative 10. So it does have an acceleration in the y direction, but we said that it's going a constant velocity in the x direction, so that acceleration is going to be 0. Now, besides the accelerations, we know one more piece of information, and that is, since it's being launched horizontally, it is going to have a velocity in the horizontal direction, some initial velocity, but it doesn't have a velocity in the y direction. In the y direction, it's just going to be dropping, and it's starting out going 0. So the y initial velocity in this type of problem is a 0. So this is the information that we know without getting any actual numbers. So let's say that the range is 100 meters. The cannonball is going to land 100 meters from where it started out. So that would be, since this is in the x direction, that's going to be the displacement in the x direction. Let's say that we also know that it's going to take 2.5 seconds for the cannonball to land. Now, there's only one cannonball, and it's not actually moving in the x separately from in the y. They're moving together. So when it lands, it's going to take 2.5 seconds for it to land, both in the x direction and the y direction. These two things are the same, and your time will always be the same for them because you only have one projectile, and it's going to have the same time no matter what. Okay, so this is all the information we know. We don't know how high up the cannonball started or how far it shot, but we can find the rest of the information. So let's say that we want to find the velocity in the x direction. We want to see how fast this cannonball was shot out. Well, if we look over here on this side, we have displacement and time, and that's what we need to find velocity. If you start with your initial equation, d is equal to VIT plus 1/2 AT squared. Remember, when acceleration is 0, this goes away, and that just leaves you with d is equal to VT, which rearranges to velocity is equal to displacement divided by time, which is the constant velocity equation that we started out the year with, just with a d written instead of delta x. So for velocity, and I showed you that it comes from this, but again, if you have your equations memorized, this thought process doesn't have to happen. You already know that in a constant velocity situation, velocity is displacement divided by time. So for our velocity, we are going to take our displacement of 100 and divide that by our time, 2.5, and we end up getting 40 meters per second. So this cannonball had to shoot out at 40 meters per second. Now, since there's 0 acceleration, we know that we have a constant velocity, so the final velocity is also going to be 40 meters per second. Let's say I want to know how high up my cannonball started. I don't know how high the building is that I'm launching it off of. Well, I need three pieces of information to use a kinematic equation, and I need a kinematic equation because this has acceleration. I have three pieces, VI, A, and T, so for displacement, I'm going to use this same equation here. Initial velocity is 0, so that goes away, leaving me with D is equal to 1/2 AT squared. One half times -10 times 2.5 squared. And when I put that in my calculator, I get -31.25 meters. The last piece of information I could get from this is the final velocity in the y direction. So at this point, I know my acceleration, I know my time, I know my initial velocity. So the easiest equation to use is VI is equal to VF plus AT. And so VI is 0, so that goes away, and I just have acceleration times time, which is -10 times 2.5, which gives me 25. 25 meters per second is the final velocity in the y direction. Now, there's another concept called impact velocity, which means that when this cannonball is actually going, it's not going 40 meters per second in the x and 25 meters per second in the y direction. It's just one cannonball. And so how fast is it actually going to hit the ground? Well, it's not either of those numbers, 40 or 25. We actually have to put them back together as one velocity, and that's going to take trigonometry to do. So if you have your cannonball coming in at an angle, it has a velocity in the x direction, and it also has a velocity in the y direction. And then how do we put those back together? Well, this vector, this is making a rectangle because this is in the x and this is in the y, and so we can just kind of put that over here, this 25, and now we have a right triangle. And so now we can use trigonometry. We're looking for this, which is the hypotenuse of a right triangle, so we'll use Pythagorean theorem. A squared plus b squared equals c squared. And so c is what we're looking for, c. And since we're getting the square, or since c is squared, we're going to take the square root of both sides, and that rearranges as the square root of a squared plus b squared. A and b are the sides, and c is the hypotenuse, and so my velocity that I'm looking for is going to be the square root of 40 squared plus 25 squared. And that gives you 47.169 or 47.2 meters per second. So now the question is, what angle is it going? Before, we just said the direction for a velocity was either positive or negative or east or west. If this were going directly 45 degrees southeast, we could say due southeast, but it's not. And so we need to give the angle at which it's going for the direction. Now, I drew it this way, but really this is how it's coming in, and this is the ground. So if you're talking angles, technically this is the angle that we want because this is the angle that it's making with the ground. This would be the same as this angle over here because of geometry, alternate interior angles. But this is actually the angle that we're looking for. This would be the same as that, and 25. So those are still our sides. Now, if you need a review of this, there is a trig review, but essentially if you're looking for the angle and you have two sides, then you can use the arctan or arcsine or arccosine depending on the sides that you have. We have the opposite and an adjacent. This one is opposite and this one is adjacent, and so that's tangent. So I'm going to do the theta, or the angle is going to be the arctan of opposite over adjacent, so 25 over 40. There's a button in your calculator for this. It's not supposed to be tan to the -1. There's literally a button that says tan -1. And once you push that, make sure that you are in degree mode and not radian mode, or you'll get the wrong answer. But in degree mode, you end up with 32 degrees. So this angle here is 32 degrees. Now there's one more kind of tricky part to it. That's 32 degrees above the ground, so 32 degrees above the horizon. You could say that, or you could say, since this is the east-west direction where the horizon is, and this is 32 degrees above that, so north of it, so you could say north of east or north of the horizon. You could also use compass directions. It's kind of tricky here, but you're just trying to say what angle you're looking at. We're looking at this angle. We're not looking at this angle here or this angle. So this just helps you know which angle. So it's north of the east-west axis or the x-axis. So our final answer would be for our impact velocity, how hard it's coming in, is going to be 47.2 meters per second at an angle of 32 degrees north of east. Okay, now it's just time to practice it.